I'm Jade and I'll be your Sec 3 Math Regular Class teacher. So in my course, we'll be going through topics like indices, quadratic equation, and coordinate geometry. During the lesson, we'll be going through some practice questions, followed by some tips and exam strategies, and lastly, we will end off with some fun facts and a short take-home activity. So make sure you have your notebook, stationery, calculator, and most importantly, an eager learning spirit. With that, let's begin. So this is a common pitfall among students. We need to bear in mind the difference between index and coefficients. So index, as mentioned previously, is also known as the exponent or power. So let's say we have a to the power of 2 or a squared. The number 2 here will be our index. So let me give you another example. Let's say we have y cubed. So this tells us that it will be y and we have to multiply itself by 3 times. So y times y times y. And let's see, for coefficient, it refers to the number before the variable. So variable is something that's unknown. So in this case, we have 2a. So a here is our unknown. So the coefficient will refer to the number 2. So this is coefficient, and a is our variable. So let's say we have 5x. So this would mean that we take 5 multiply by x, since 5 is the coefficient and x is the variable. But what happens if we put this together? So if we have 5x whole thing squared, so this would mean that the power is multiplied to both variables. So this will give us 5 squared multiplied by x squared. So after we simplify, we will get 25x squared. Great job. Let's move on to question C. So here we have 2a to the power of 4, b whole thing bracket to the power of 2, divided by 16, a cubed, b squared. So firstly, what I want to do is to expand the powers outside the bracket. So we will have 2 squared, a to the power of 8, and b to the power of 2, divided by 16a cubed, b squared. Next, we can group the common variables together. So we have 2 squared divided by 16, and then a to the power of 8 over a to the power of 3. And lastly, b squared over b squared. So you can key into your calculator, and you should get 1 over 4. For this part, you will have a to the power of 5 over 1. And since it's b squared over b squared, we can just simply write it as 1. Next, we can combine all the numerators together. So we have a to the power of 5 over 4. Let's move on to part D. So here we have 3ab whole thing bracket to the power of 2 divided by 3ab bracket to the power of 3. So what we want to do is to expand the powers. So we will have 3 squared, a squared, b squared divided by 3 cubed, a cubed, and b cubed. Next, we can convert this into a fraction. So we got 3 squared, a squared, b squared divided by 3 cubed, a cubed, and b cubed. Next, we can group the common variables together. So we have 3 squared divided by 3 cubed, followed by a squared over a cubed, and lastly b squared over b cubed. Now we can simplify, which will give us 1 over 3 times 1 over a and 1 over b. Next, we can combine all the numerators and all the fractions together. So we have 1 over 3ab. So this is just the first method. Let me show you a second method. Okay, so in method 2, we will utilize substitution. So for 3ab, it can be thought of as a new term. So we can simply write, let 3ab be, let's say, letter y. This will give us y squared divided by y cubed. So then we can convert it into a fraction, which will be y squared over y cubed, giving us 1 over y. Lastly, we need to substitute 3ab back into this equation. So we will have 1 over 3ab. So you can see that both methods will give us the same answer. So there's no one right way to do indices. It all depends on how you utilize the laws. So to understand fractional indices, we can use a flower to represent it. So let's say I'll draw a flower here, and these are the roots. Okay, so we will have a base and a fractional indices. So here, we can think of the numerator as like a flower. And flowers are pretty, so we want to keep them. And for the denominator, they can be seen as the roots. So what this means is that when we have a to the power of 1 over n, what we want to do is keep the numerator and root the denominator. So this will give us n root a. Okay, so let me illustrate this with some examples. So we have 4 to the power of half. So in this case, the numerator is 1, so we will keep it, and we will square root because the denominator is 2. And next, we have x to the power of half. So same thing, we will keep the x and square root it. And lastly, when we have x to the power of 1/3. So same thing, keep the numerator, and we want to cube root. So what happens if the power isn't 1? So in this case, we have a to the power of m over n. So same thing, we want to keep the numerator and root the denominator, which will give us am and root n. So let me illustrate this with some examples. So if we have 5 to the power of 3 over 2. So what we want to do is keep the numerator, so we got 5 cubed, and we want to square root the whole thing. So moving on, if we got x to the power of 4 over 3. So we want to keep the numerator, which is x to the power of 4, and cube root the whole thing. So lastly, we have 8 to the power of negative 1 over 3. So this one involves a bit of negative indices, but not to worry. So we will keep the numerator and cube root the whole thing. So 8 to the power of negative 1. To get rid of the negative sign, we flip it over. So we got the whole thing cube root 1 over 8. And lastly, for x, the power of negative 2 over 4. So we want to keep the numerator, and we got 4 root. So to get rid of the negative sign, we will flip the x over. So we got x squared. So for level 2, we need to find a common base between both sides of the equation. So we have 9 to the power of 2x minus 1 equals to 27, 3 minus 4x. So here you may see that a common base will be 3. So 9 can be represented as 3 squared, so 2x minus 1 equals to, and 27 can be represented as 3 cubed. So remember to put your brackets there. Okay, and now we can utilize the laws to simplify. So we got 4x minus 2 equals to base 3, 9 minus 12x. So now both bases are the same, and we can compare the index. So by comparing, 4x minus 2 equals to 9 minus 12x. So you can rearrange and shift all the x on one side. So 4x plus 12x equals to 9 plus 2. This gives us 16x equals to 11. Lastly, to find the value of x, we can divide by 16 on both sides. So we have it, x equals to 11 over 16. So moving on to question B. So for question B, we have a base 25 on one side and base 125 on the other. So we need to find a common base, which is base 5. So we can change 25 into 5 squared. And remember to include 1 minus 3x. On the other side, we know that 5 to the power of 3 gives us 125. And include power x minus 1. Next, we can simplify the powers outside the bracket. So we have 5 to the power of 2 minus 6x equals to base 5, 3x minus 3. So now the bases are same, we can compare. So we have 2 minus 6x equals to 3x minus 3. So same thing, we will shift all the x onto one side and all the numbers onto the other. Okay, so we got minus 9x equals to minus 5. So from here, we know that x equals to 5 over 9.